You want to, year 12 and 13, this is a short question from the 2014 Scholarship Calculus paper. So this is question 5 and it's part A. So this was worth 4 marks. It's a really straightforward 4-mark question that you can just about expect to find in level 3. Now you're asked to show that this is a solution of this DE. So as soon as you see the word differential equation, you probably think about what you learnt in integration. But this is actually just a differentiation question where you have to use a chain rule so that you understand logs. There's not that much to it. So you might want to pause here and just start by doing the obvious things, which are to differentiate this. Okay, and you're going to need to get to the second derivative. Okay, well hopefully what you did was this. Well, this is one way to do it. Well, I'll show you another way at the end. But the most sort of straightforward way is to say, what's my first derivative? Well, I've got e to the power of something. So it's going to be e to the power of the something function times the derivative of this thing here. So it's a straightforward application of the chain rule. So it's times c e to the cx. Okay, and we can write that more tidily as ce to the cx times e to the power of e to the cx. Now don't ask me to think of a real world application of this dE. I'm sure there is one, but I don't know what it is. Anyway, that's my first derivative. Now I need to differentiate that again to get my second derivative. So that's just going to be the product rule. So we'll do that on the next slide. So d squared y by dx squared is going to equal, well, first factor, c e to the cx, times the derivative of the second. We've already got that. So it's c times e to the cx times e to the cx plus the other way around. The second factor, which is e to the cx, times the derivative of this bit here. Okay, I'm only highlighting this because I haven't got the first derivative function written out on this slide, but you'll have it in front of you hopefully. So that's going to be c squared e to the cx. And we can clean that up at this point and we get c squared times e to the cx times e to the 2cx. Let's say this bit, oh, a different colour, this bit and this bit, plus c squared e to the cx times e to the cx. Now there are a couple of ways to go here. You can start trying to figure out what's y and what's log y, or you can factorise, which is obviously what's going on in the differential equation. Right, so we'll take out what we can. We've got a c squared times e to the cx. There's that bit done, that bit done. Now here we've got this, and we've got this. So we're going to take out another common factor, which is e to the cx times e to the cx plus 1. So we look like we're getting closer. What we've got to do now is to figure out what was y and also what was log y, because they are both featuring in my differential equation. Okay, so what we had, I'll just copy out what I had from the last slide. So c squared e, you can forward through this bit. Right, now remember y was equal to e to the cx, so we can obviously pop that in there. Let's have a look at what log of y is. Well, log of y is the log of e to the cx, and that's just going to give me e to the cx. So that's great. That means that now I've got c squared times y, so just put those bits in little boxes, c squared y times the log of y times the log of y plus 1 as required. Now that was worth a whole 4 marks, and I don't really think there's much to it. If you're looking for some more practice at those, there is a whole chapter in the old Delta book that is lurking in the integration section. But as I said, this is really just an application of differentiation. Okay, thanks for watching, and there is another way to do it that I've just remembered I haven't put in this video, which is to first take logs of both sides. So if you want to have a go at that and then show me in class, I'd be happy to have a look.